Okay, so it's the last talk of the day. We saved this one particularly because we needed, I'd say, some top-notch presenters with a top-notch subject, and I hope you agree that we've got this by the end. After this talk, you're going to go upstairs. You're going to follow the line of crew to the door. You're then going to go out of the door and walk straight across the road, and the hotel security staff will help you do this, we hope, because we don't want you run over by a taxi or two. And then you'll be told where to go. MWR are going to throw an awesome party this evening, and I hope to see you all there. So enjoy the talk, and see you later.
Wow. Good evening, after all. Well, this is a quite daunting place to be. If you have a look at the rooms when they're quite small, you think, yeah, that's easy. That's really piss easy. It's nice and small and cozy. And then you have all these faces on you. And the last time I was in a position like this, it was a courtroom. So welcome to our talk. It's about terrorism, tracking, privacy, and human interactions, which is quite a media-friendly topic. And as you see as we go through, it's quite entertaining, to say the least. So, first things first, my name's Daniel Cuthbert.
My name's Glenn Wilkinson.
And we work for a company called SensePost. They're South Africans, but are also now based in the UK. So let's break the ice here. I'm gathering quite a few people here who have got smartphones. Raise their hands. Cool. Anybody got their Wi-Fi turned on? Don't lie, come on, let's cut the bullshit. Right, so who lives at 104 to 108 Sutherland Avenue, Fenham, UK? What about 5 Elizabeth Road, Liverpool? There's somebody from 138 Middle Street in South Africa. We have Dracula in the house, which is quite cool. Dormiton of the Theotokos Cathedral in Romania. Really cool. Please come back after the talk because you get a prize for the best thing. So is anybody going to own up to being at that location? Yeah? You're the Romania? Oh, damn it.
So
that's pretty cool. Your house is really cool if it's there. We're not going to go into any more details, right? But welcome to the party. So, a bit about us. We've been involved in security for a while. As I said, we work for a company called SensePost. If you want to follow the ramblings of a madman, please follow me on Twitter. We have our official SensePost Twitter account, which is sensible and cool, and then Glenn's rather interesting Twitter account.
I'm from Zimbabwe, ZW.
Sorry about that. Right, so I guess we have to talk about the elephant in the room. We are in the United Kingdom, and let's face it, the UK has some rather strange laws when it comes to interception, misuse of computers, data protection, etc. Now, doing this talk, and when we proposed this idea about the talk, we had a lot of input from people we look up to in the industry. And the key thing here was staying within the law, right? Now, this is probably the hardest thing Glenn and I had to do career-wise. And with anything when it comes to security research, there is a very fine line. And staying on the right side of that fine line was pretty hard to do. If you go on the bad side of the fine line, you are going to get visited by the Met CCU. You'll spend 8 hours in Belgravia police station with no shoelaces, and you'll pretty much have a crap 10 months. So with that in mind, everything that was performed in this talk is legal. No interception was performed. No Computer Misuse Act was broken, no RIPA Act was broken, no Data Protection Act was broken. Do not arrest us. Thank you very much. So, Glenn and I have become really obsessed, and it is an obsession now, especially when it spans 6 months, God knows how many continents, and whipping out little devices everywhere, with the way that mobile phones have evolved, and how Wi-Fi usage, and effectively how people have started to live their lives on these devices. So we love big data, and we love the fact that there's security services out there and governments who take all this data and do stuff with it. Now, we can't comment on that. We have no idea what the MOD or 5 or 6 or CIA or FBI is doing, right? So when you look at companies and governments like Labour and the security services, anybody in here? Hey? Cool. We know what you're doing. We've got a lot of databases. I'm sure you're doing some very cool stuff that none of us will ever know about. But there is one company that does get us quite excited. It's a company called Palantir. Now, Palantir, as anybody doesn't know about them, is a US-based company, And they create a really cool piece of software written in Java that effectively is offered to governments and security services and police forces, etc. And it plugs all their databases into a single location. Now, what Palantir allows is for anybody in that arena to do lookups on people and look for patterns and look for statistics and everything else. Effectively, it's a spook's wet dream. So I'm going to give you a little story of how the world has changed and how data has changed and how we deal with data. So for the first off, we have a guy called Mike. Now, we're not going to do any racial profiling here. Here's Mike. He lives in Egypt. And he decides that he's going to buy a ticket from Cairo one way to Miami. Okay? So when he gets into Miami, he does what most people do. He rents a condo, normal condo, nice everything by the beach, really cool. And he goes around and he's buying stuff with his Russian ATM card and withdrawing money, as you do. And he gets a cell phone and he gets a data plan and he's calling all his friends in Syria. We've all got friends in Syria. He then decides he needs a set of wheels. So he goes and rents a truck. Not a Chevy, not a Camaro, a big fat truck. All right? And he decides he's going to drive around to all the cool sites that Miami has and visits Disneyland. And as any tourist from, out of town does, decides he's going to take lots of pictures of the security gates, their alarm systems, their guarding systems, etc. Now, that's pretty normal. I mean, we all do that. I mean, Glenn and I walk around airports with weird devices. Where Mike screwed up was that he decided his left foot was a bit heavy. Sorry, my slides have gone funny. So he decides he's going to drive along in his truck through Miami, and he's going to put his foot down, and he gets caught. And he gets caught in a speed trap, right? Now, before that, he wasn't really being monitored. He wasn't really being tracked. But the police officer, a really good police officer, and he puts his name into a database and says, right, well, what's this Mike up to? What's he doing? Now, thankfully, because that police department used Palantir, when he puts that name into the database, all those individual actions that Mike did before start to pop up, and we see patterns. We see the fact that, number one, he flew from Cairo one way to Miami. We see the fact that he rented a condo, he was drawing money from a Russian ATM, he was buying cell phone with data usage, and he was calling certain key people. We also see the fact that he rented this truck, he was visiting Disney World, the logs of the toll booths and the ticket stubs were all monitored, and also the fact that he was taking pictures of security installations. So prior to 9/11, this kind of information wouldn't really have been captured. We wouldn't know how to see a pattern, right? And this leads me into a really cool quote by our lovely lady, Theresa May. This is all about making sure that the police and security service can continue to catch criminals and stop terrorists. And this is quite key. But the problem is, you'll only have this technology if you've got oodles and oodles of cash. Last year, Palantir raised another $100 million in venture capital funding. It's not a cheap product. So being, from the African continent, Glenn and I are quite cheap. So we thought, well, how can we, play around with this? How do we get access to this? So I'm going to introduce you to the most sophisticated surveillance piece of equipment you will ever see. The mobile phone. It's lightweight, it has long battery life, it connects on many, many networks, Wi-Fi, GSM, CDMA, Bluetooth, it allows you to store data, and everybody's got one. And best of all, it's approved by the security services. So, a little bit of stats about mobile phone usage. In 2009, Ofcom did a report, and they call it the Communications Market Report. And they look at the behavioral patterns of people on radio, television, and buying devices. And in 2009, only 1.2 million smartphones were sold. For that same amount of people, they all admitted that they did not use it as their primary internet device. So a very small amount of the population were using it. If we fast forward to 2012, July 2012, with the same report, Ofcom reported that 2/5 of UK adults now own a smartphone. And at the same time, that same number of people use it as their primary device for accessing the internet. Which, if you're blonde like me, 2/5, I don't know what the hell that means. So, according to the last consensus, there are 62,641,000 people, give or take, in the UK. All right? So 2/5 of that means that 39% of the UK population are currently using a smartphone. And when Glenn and I started this research, it's amazing how quickly you pick up how many people are using the mobile phone. Got on the tube yesterday, a nice couple got on, sat on in front of me, didn't say a word to each other, both were glued to their smartphones. We've become addicted to things. It's a bit like that horrible jingle from the UK talent show, "Where's my keys?" or "Where's my phone?" Everybody's effectively got one. And another staggering fact is that in 2010, so 2 years ago now, 43 million hours were logged on Facebook alone. That's a hell of a lot of pictures of babies, baby puke, and cats. But again, I'm blonde, so how many days is 43 million hours? Well, it turns out it's 1.791,666 days. That's a hell of a lot of time on Facebook. So if you were looking at monitoring people, getting to understand how people use these devices, there's already a lot of data out there of people doing it. So what if there was a framework that was available that allowed you to monitor people's movements, work out what traffic they were browsing, where they were and where they'd been, but also didn't cost hundreds of millions of dollars? Okay, so this brings us into what Glenn and I have been doing for the last 6 months. We'll bring it over to Glenn.
Tag me in. All right, thanks, Daniel. So as Dan mentioned, we've been working on a project for the last few months. But before we get into the details of that project, I'd just like to make sure that we're all on the same page in terms of background knowledge. So a few background ideas first. The concept of war driving will be what we'll chat about first. So war driving is a funny sounding word, but it's quite a simple idea. All it relates to is mapping a whole bunch of network SSIDs, so network names, to locations. And it's quite easy to demonstrate. Here we have a map of London and a whole bunch of network points all over London. Up in the top corner there, we've got Glenn, and he's got some kind of mobile device, maybe it's a cell phone, but that device has both Wi-Fi capabilities and GPS capabilities. So what does Glenn do? He wanders all over London with this device, and each time he comes across an access point, he records the GPS coordinates of that access point. So there we have Virgin AFVT logged at those coordinates. He keeps wandering around town. Each time he detects a new wireless access point, he notes the GPS coordinates. And he builds up this nice big table down here. But as you can expect, the amount of work required to build up a big table like that, Glenn's going to be quite busy for a long time to profile the whole of London or the whole planet. So lucky for us, other people have done that already. So you may or may not know, but Google, when they did their Street View business, so they drove around in their Street View cars, they weren't only taking photographs, they were doing exactly this. Their car had some Wi-Fi capabilities, and every time they noticed an access point, they made a note of the GPS coordinates where it existed. There are other commercial services like Skyhook. So Skyhook, you can query so GPS coordinates and associate them to network names. But those are all fairly commercial or fairly restrictive. There's a fantastic service out there called wiggle.net. So it's about 10 years old now, and it spawned out of DEF CON about a decade ago. And it's a user-contributed site. So anyone can run the software on their smartphone or their laptop and upload tables like this to Wiggle. And currently Wiggle has, I think, around 70 million entries in it. So 70 million networks from all over the world, we know the GPS coordinates of those devices. And I've been working with the Wiggle guys a little bit during this project, and they're a fantastic bunch of guys over there. Okay, so that's one little background bit of knowledge for you. The other one relates to how Wi-Fi works in general, how the protocol works, how the protocol has been designed. And when you've got your Apple iPhone or your BlackBerry or your laptop or whatever, any wireless device, anytime you connect to a wireless network and choose to save that connection, that point going forward, your device will always be looking for that network. It won't wait for that network to announce itself. It'll actively send out messages saying, hey, are you there, Starbucks, or whatever the network happens to be. So there's my iPhone. And last week I connected to a network called BT Home Hub. So now as I sit in this room, my iPhone is shouting out, hey, BT Home Hub, are you there? I want to connect to you. Starbucks, are you there? I want to connect to you. Virgin AFVT, are you there? I want to connect to you. Is anyone out there? So all of your smartphones are currently doing that. And Apple people sometimes say, no, this is only an Android problem, or yeah, if you upgrade to the latest iOS or whatever. No, so I haven't seen any devices that don't exhibit this behavior unless it's a very technical person who's locked down the device. Now, why is that interesting? So the phone's not only sending out those probe requests, so those messages are called probe requests. It's also sending out its MAC address, its unique identity number, when it sends out those messages. So if I have some kind of monitoring station, like I've depicted up there, I can run some software that listens for these probe requests and saves them somewhere. So I see the smartphone sending out those probe requests, and I notice that it's shouting, hey, Virgin AFVT, are you there? And from the previous slide, where I did that little war driving exercise, I look in my database, and I say, look, Virgin AFVT at those GPS coordinates. Therefore, instantly I know that this device has at some point in the past connected to a network at that exact location. And then I can plug those GPS coordinates into some Google APIs or some other mapping APIs and get a street address. Okay, so this device connected to a network at 3 Main Street. I can then plug that into Google Street View and get a picture of your house, which is perhaps why some of you saw a photograph of your house on the first slide. Okay, so that's one thing that's quite interesting. Now, something else. So when that device is sending out those probe requests, my little monitoring station over there can be cheeky. It can respond to all of those and say, yeah, that's me. So I'll say, hey iPhone, it's me, Starbucks, why don't you connect to me? And it can respond to all of those probe requests for all devices and basically pretend to be that wireless network. So if you're sitting, watching, you'll see a wireless network with the name Starbucks suddenly appear from nowhere.
Remember we talked about that thin red line?
Yeah, that's the line that if you cross, you might get in trouble. Point being that at that point, the iPhone will say, hey, Starbucks, and it will associate to my device in the corner there, and I'll get its internet served via that device, allowing me to intercept traffic or modify traffic in any way. All right, so that's a little bit of the background knowledge. So today, we're quite excited to introduce a tool we've been working on called Snoopy, as depicted by this lovely giant Snoopy character now. He looks quite small down here, but Snoopy the dog. Now, what is Snoopy? Snoopy is the result of a few months of work. So I'm not a full-time developer or researcher, so those 4 months don't really depict perhaps the scale of the project. But nonetheless, a few months of work. And Snoopy is a distributed tracking and profiling framework. And it consists of 4 key elements. So it consists of a bunch of client-side code, client-side scripts, which you can run on client-type devices, a bunch of server-side scripts, which process server data, a bunch of, a web interface to manage the server-side components, and some data visualization and manipulation tools. So there's 4 key components there. Now, when you all walked in the conference this morning or today at some point, you probably walked past the registration desk. And it's likely that you met one of our friends. His name is Drone001. And this is him here. He's a Nokia N900 phone. And as you entered the conference and walked past this device, it saw you. And it noticed, hey, there's a Apple product, and that Apple product is screaming out these network SSIDs, BT Home Hub 123, Virgin Media, this, whatever, and it recorded all of that data. And this is the Snoopy client. So when I mentioned monitoring devices earlier, this was what I was talking about. Now, if you want to be kind of monitoring people and intercepting that kind of traffic or bringing up these rogue access points, if you're wandering around with a laptop and an Alpha card and maybe a satellite dish on the end and a balaclava, because all hackers wear balaclavas, you look slightly suspicious. But if you're wandering around with a smartphone, who's going to notice? The point being that the Snoopy client-side software runs on any Linux-based device that has wireless capabilities and supports packet injection. So the Nokia N900 looks like a phone, but it's actually a full Linux box. Also, I've got a Shiva plug here. So this is another one. This one's great because it's you can plug it into a wall and leave it. You can put a sticker on it so it looks like an air freshener perhaps and disappear. Over here, I've got an Alpha R36. So it's an access point, but fairly small form factor, comes with a battery. I've got a 3G dongle for internet connectivity. And a battery pack here, which can power the N900 for up to 8 hours. Another N900 and a Raspberry Pi. So a cool project, if you've got a Raspberry Pi, is to play with Snoopy, perhaps. So point being, they can have lots of these different devices running the client-side software. So I see you in the front row there, you've got a BlackBerry, and you're busy checking your mail. What you may not know is that your BlackBerry is currently sending out this probe request looking for those networks. Someone at the back there's got their laptop open, doing the same thing. It's looking for those networks. So this device is currently listening for those probe requests, saving them to a database, and using a Wiggle API I wrote, which is basically just a page scraper, looking up the GPS coordinates of networks you've connected to, and then using Google Maps to pull an actual image. So that's quite cool. And when I started working on this, it seemed to be original work. There are other tools which now do this, the curse of research and time to publishing. So what Snoopy also does is, which I think is really cool, is it'll bring up a rogue access point. So it'll say, hey, I'm Starbucks, I'm BT Open Zone, and then you guys will connect to it. And lo and behold, you'll get your internet access via this device, none the wiser. And existing solutions do exist in various forms that can do this. But where Snoopy differentiates itself in the first way is that distributed word that I mentioned. So the first idea of it being distributed is that as opposed to saving data locally on this device, which is how most solutions work. If you want to capture data or save some data, you capture it to this device, then maybe later you go and you plug in your laptop, you download the data, you open up Wireshark. That's a real pain. And I found that to be quite annoying. So what this device actually does, and why I call it a drone, is because it's fairly dumb. All it does is it captures data and then sends it to some server I've got on the internet there. So it captures data and passes it straight through. It doesn't store anything locally. And why that's cool for a few reasons. One, we can have multiple of these drone devices. So all of these devices I can plug in various places, and they'll all kind of get this data together and push it to that central server. So you can see how that can be quite powerful for a tracking type solution. Drop one of these devices in every underground station in London, and all this data gets sent to the central server here, where you can look for, say, travel patterns of people. Someone jumped on a train at this station at 6:45. We then observed them again at this station at 7:15, and then again at this station later in the day. And then over a period of a week, we noticed that they leave their home between 7 and 7:30 every day. And then over a period of a month, and then once you have kind of 100,000 people or 700,000 people, you can look at patterns of how an entire population moves. And now we can do the lookup on the server as opposed to the clients. Now what's also really cool, of course, is that we can bring up the rogue access point and start handing out free internet to everybody without them knowing. So your device will automatically connect to this guy because it thinks that it's in Starbucks, it'll connect, and you'll get your internet served via this device. Now that's really interesting. So you can have 50 of these devices in the field. Each one of them can have 50 clients connected to it. So 2,500 clients or victims connected simultaneously with all of their internet traffic going through at one point on that server. So what does that give us? Well, Snoopy uses a transparent squid server, and I've written custom logs such that your cookies, your IP address, the website you're visiting, all that gets stored into a MySQL database. It also plugs into SSL strip, so any SSL websites that you're visiting, potentially we can grab your credentials out of that. It's also got a man-in-the-middle proxy Python script, which allows us to inject arbitrary HTML or arbitrary JavaScript. So, for example, you could replace every image in traffic with a picture of a funny cat. Or if you're being more malicious, my colleague Willem wrote a really cool bit of JavaScript which will profile the device. So it'll inject a bit of JavaScript which will figure out what plugins are installed, what OS you're using, and that kind of thing. It's also got a traffic inspector, which will pull out PDF documents and VoIP conversations from network traffic, and a bunch of social media APIs and plugins. Because if we're intercepting your Facebook traffic, we can grab your Facebook, whatever user ID or cookie, and from that, grab your friend, write code to grab your friend lists or your inbox or any of that kind of thing. And this becomes very interesting because of the scale of the project. This kind of stuff you can do locally, maybe on your laptop or something, but when you have 2,500 devices or clients or victims connecting at the same time, you can build up some very interesting graphics. So what do you do with that amount of data? So that's the next point where Snoopy maybe kind of tries to differentiate itself. So the old school method, if you guys are pen testers, which is my day job, and if you do any kind of traffic interception, maybe you steal some cookies, well, then you grab it out of the Wireshark logs or your Burp logs or something, and you copy and paste that into some browser plugin or something. It's kind of clunky. And when you're dealing with this kind of data, you need to automate that process. So Snoopy has two components to deal with the actual captured data. So the one is a web interface, which my colleague Volta has been working on. And here's a quick screenshot. So the map over there depicts this device in my pocket as I was walking around some neighborhood in London. So I'm walking along, and it records the GPS coordinates of my position as I walk along. And if I click on any of these points, that list on the left there is a list of all client devices within proximity of me. So all of those people there were within proximity of me at that point in time and that point in space. Also, if we click onto one of those clients, like we click on that client down there, so that's a person's device, there's a list of all the networks that they're currently probing for. And we can map that with Wiggle onto a map. So this person has clearly visited the east coast of North America, hopped around Europe quite a bit, been to Asia, and been to Australia. So this is one interface to interact with the data. And there's another one which is equally exciting.
Thanks, Glenn. So one of the first problems that we had when we were dealing with Snoopy, and especially the distributed nature, is that we were collecting so much data we didn't know how to handle it. And at SensePost, we like to work with really intelligent, sexy people. And thankfully, Rulof, Andrew, and Chris are really good friends, and they helped us out with this matter. So I think this is the first time Maltego Radium has been demoed in the UK, which was released on Monday. And we've been working with Rulof and Co. for a while, and Rulof's allowed us to effectively take Snoopy to the next level. So when we have multiple drones around, say, a city of London, and we've got 6, 7, 8, 9, 10 busy collecting data, we want to see it in real time. Now, the problem we had before with the old tools was that they were always saved on a single location. You had to upload it, put it into a database, and do something with it. The cool thing about Maltego Radium is that they've introduced the concept of machines. So in previous versions of Maltego, you had to know what you were doing with transforms. So it was still very powerful, but you had to know, do a DNS lookup, do a dig, do it, etc. If we had the same function in Snoopy, we would be struggling for stuff. But with Maltego Radium, effectively we've built our own Snoopy machine. So we can now poll our central server in real time and get a real-time list of clients connecting. If we were illegal and breaking the law, not only can we see which devices are around us, we can grab all their credentials, we can inject stuff, we can modify their traffic and completely take control of whatever that device is. So Maltego is really, really exciting. We're really happy that Rulof and Co. have worked with us in this. And Glenn's going to do a demo now of this in action.
Okay, so I've got, I'm going to say 2.5 demos. I say that because 2 of them are pre-recorded. One's going to try and be a live demo, but you know how demo gods are. So the first demo, I'm going to be demonstrating Maltego, and the first demo is looking at data that I collected at 44Con this morning and yesterday, and at Black Hat Vegas in July. And what I'm looking for is an overlap of devices observed at both these locations. So here we go, there's a little Snoopy dog, and I've written a little machine. So all it is a little script which pulls the database. So those, 3, 6, 7. So those 7 devices, as of, I think, yesterday evening actually, were observed at both Vegas Black Hat and 44Con at some point yesterday. And next, there we see for each of those devices, those are all the network SSIDs that they're looking for. So that guy's looking for Black Hat. There's a few people looking for Black Hat. Caesar's Palace, etc. And then from that point, we could further geolocate each of those SSIDs to a location, either plot it on a map in the web interface, or just get the location and a street view photograph here, which we'll see in the next demonstration. Okay, so that's really cool. I mean, it's a simple little thing, but I can't think of another way to make that correlation. So to put it into context, I think in the order of 80,000 devices have been observed in our database. So from 80,000 devices, we're sucking out just those 6 and making the correlation between 2 different points in time. And you can apply that in various scenarios. So you can look at, so who was here, who came from Oxford Circus Station this morning, because we observed them in both those locations, for example. So the next demonstration only looks at 44con data. So this is from data I collected yesterday. And what it does is we'll look at all devices, so all cell phones and laptops that were probing for networks yesterday, and we'll get all of the SSIDs, but then we'll only keep the SSIDs that have more than one client probing for them. So for example, something like, so if Barang is probing for Virgin Media 123 and he's the only person probing for it, then we ignore it. But if there's a network that say 3 people are probing for, then we keep it. But also if there's a network that more than 10 people are probing for, we ignore that one as well and prune it. You see it just got pruned there. So a whole bunch of nodes disappeared, only the big green ones stayed. And the big green blobs are the names of the networks that people are probing for. And there we see the 44con crew. And that's interesting. So it looks like there's 7 devices, 7 people who belong to the 44con crew. So you see 7 people probing for that network. So let's see if we can explore that a little bit. And we see the names of the devices. The names of the devices are derived from the MAC address. So I could display MAC address, that's not so cool. I thought displaying the name of the product might be more interesting. Okay, we can chuck those into a new graph. Okay, so we have these 7 people who are part of the 44con crew. Right, so now let's pull the data up again. So we narrowed it down, let's pull it back up. So let's figure out what network SSIDs the 44con crew people are looking for. Okay, so this gives us a little bit of insight into the guys who run 44con. These are the networks that they've been looking for. Emirates Palace, for example. So what we can do, we can fetch location, and this uses the Wiggle plugin to actually fetch the location of that particular, so, well, as expected, I guess, United Arab Emirates. So I think that might be you, Adrian. And we get the street address or approximate street address up top there, as well as the GPS coordinates, and potentially a photograph. It seems that one didn't have a photograph from Google Maps. Okay, so that's interesting. Where can we go with that? So the Wiggle lookup, it's a little bit slow. So I highlighted all of them and said, look up on Wiggle. And to save us time, here's the result. So for all the 44con crew, these are the locations that they've all visited. Now, in the icons, I just display the country code and then a photograph from Google Street View. So USA, UK, yeah, someone else in the UK. And the interesting thing is, well, I'll discuss it in a second, actually. So here's some more. Couldn't locate a bunch of them. USA. Italia, potentially. DEFCON Secure. ShmooCon. Some more in the USA. And now what's interesting is, as security people, we've been telling people, with your wireless networks, make sure you choose, a unique name for the network. So don't just call it internet, call it BT Home Hub 6149 or something random. And the reason behind that is that with WPA type encryption, the name of the network is used as part of the salt for the password hash. So if you use just the word internet, then it's probably rainbow tables or whatever that can be used to crack your WPA a lot quicker. But as a side result of that, for this war driving concept, because your network name is unique, that means because of services like Wiggle, I can plot the unique name BT Home Hub 12649 to an exact location. Whereas if you had called your internet, then there's a million access points called internet, and I would be none the wiser. Okay, so that's interesting. So now I know where those dudes live, or where they've traveled to. What else can I do? Okay, let's get rid of the network names. Let's scrap that. And let's see if they're perhaps connected to my rogue access point and accidentally surfing and accessing their web through my device. Whoops. Yep, it's the 9gag. Who's browsing 9gag? They're all on Facebook. So there's Chris on Facebook, Adrian on Facebook. Now what I'm going to do, let's just select the Facebook entities. So delete everything else. As an aside, this is a demonstration of the old way to use Maltego. Now I had wrote a machine that would do this automatically, but a slight glitch before the show meant that I couldn't automate this. So there we go. Now we're grabbing all of their Facebook friends. Since we've intercepted their Facebook traffic, we now got their cookie or their Facebook user ID. And now another script grabs their Facebook profile and starts pulling out all of their friends. And you can see that the big nodes, because this is what's called an edge-weighted view, where there are lots of connections coming in, it's a bit bigger. So up here, who's that? And there's Roloff Temming. So it seems quite a few of the 44con crew are friends with Roloff Temming. Who's that? Tracy. Charles van der Volt, common friend there. And yeah, so that process that you saw, that kind of, we have to click one thing at a time, as opposed to the previous demonstration where it all happened rather automatically, that differentiates between the old Maltego and the new Maltego. So the new Maltego is really cool because you can do that whole process you just saw there with a single click. Okay, now let's try a live demo.
We go to mirror display. We might have to scroll over. That's there.
So if I go to Maltego down there, and
Each one of you. What do you want to do?
I want to, oh, there it is down there. Okay, so it's actually running at the moment. And this is live data from this room of you guys. So smile, you're on candid camera. And you all lied when you said you turned your Wi-Fi off. Okay, so point being that I can run a Maltego machine that pulls this data every kind of 10 seconds or every 20 seconds or whatever and repopulates the database. Now the interesting thing is this comes from multiple devices all over. So this one's just running from this one here, and in fact two. So this one here, and Daniel left one downstairs. But we could drop these, whatever, all over London and visualize this stuff all at the same time from one central point.
Press play. Sorry, press play.
Play, so that. Okay, so come up at the end and I'll give a more detailed run if you like. One other interesting point about the Snoopy framework is that because these devices, so your victim connects to this device and that device connects to the server, and this happens over an open VPN connection, so you have effectively a transparent connection from your server to your victims. What that means is you can run Nmap or Metasploit or whatever from your server directly against all of those hundreds of connected victims on the far end. You don't need to have any sophisticated software on your drones. It could just be a very simple device. All it does is pass traffic around. Unlike, say, the Pwn phone, which has all of its junk on that thing. Okay, so let's talk briefly about a field experiment. So about 2 weeks ago, myself and Daniel and two of our other London-based colleagues went and sat in a bunch of train stations and underground stations in London with a bunch of Snoopy clients during rush hour. And we collected a whole bunch of data. We combined that data with the data from Vegas, so a few days in Vegas. And here's a few graphs which I think are slightly interesting. So the number of unique devices that I observed during this fairly short time frame was almost 80,000. So almost 80,000 unique wireless devices were observed. Now this is a logarithmic graph. So you can see the vendor across the bottom there. So Apple had 60,000 devices. In second place, HTC with 5,000 devices. So take what you want from that statistic. Same data represented as a pie chart. We see that Apple has over 75% of observed devices. Again, why is that? Are Apple devices more popular, or Apple users aren't as tech savvy and leave their Wi-Fi on? I'm not sure. That's just the raw data. Another interesting graphic. So this one depicts the average number of SSIDs per vendor. So the average number of network names that devices are shouting out. So on average, Apple devices were sending out, say, 5.5 network names that they previously connected to. But again, it's not represented here, but there was a fairly large standard deviation. So I think, at least with Apple, one device I saw was shouting for 35 different SSIDs. Some were shouting for 0. And there's no documentation on how many on those numbers. Now this one was hard work. Hard work in an unusual way. So I went and I sat in a King's Cross station for 13 hours. I found a very uncomfortable bench, the most uncomfortable one I could find, and I sat there for 13 hours with a Snoopy device. Now, of course, if I was to approach this in a more real-worldly way, I'd probably just go plug this thing into King's Cross station somewhere. But if you're kind of skulking around and you plug this thing in and someone catches you on CCTV, well, I don't want to deprive you guys of this talk, so I'll probably be in jail now. So I sat there and pretended to work. Well, I was working all day. And it made an interesting graph. So again, on the y-axis, the number of observed devices. On the x-axis, the chunks of time. So you see between, say, 8 a.m. and 9 a.m., I saw almost 4,000 devices. And then the number of devices drops a bit. At lunch, it peaks a bit. And then evening, quite a big peak.
So I think you agree, it's quite a cool framework, and we're really excited about it because what it's done is it's taken the onus of the single person running on a laptop and allowed us to farm it out to as many individuals as you want. So if you had the money and the means, you could buy 100 drones, you could buy 1,000 drones. Now, besides the government spoofing and looking for terrorists and everything else, what we're really keen on is, what would you do if you had this data? What would you do if you had a Snoopy implementation and 100 Nokia N900 devices at your disposal? Quick 2 minutes ones. Anybody? Sorry?
Take over the world, he says.
Take over the world. Cool. Okay, well, why not? So Glenn and I got some ideas. We'd love to, play with Palantir and everything else, but we'd never get a chance. So the way we see this kind of technology and this framework working was really aptly summed up in a scene from Minority Report.
A road diverges in the desert. Lexus. The road you're on, John Anderton, is the one less traveled. Make sure you follow
Good evening. You can move the old-fashioned John Anderton. Every 21 stands provides gourmet cuisine. John Anderton! You can use a Guinness right about now. John Anderton.
Escape from it all, Harrison. Get away, John Anderton. Forget your troubles.
Slow, John.
So besides the fact that that's in their eyes, here's a scenario. Let's look at a marketing point of view. Evil marketers. Let's say you have a fancy clothing shop that sells skinny jeans and makes people have really cool haircuts. And you decide you want to be in the mecca of cool, Dalston, right? But you're not sure how many skinny jeaned, cool herring wearing people actually go to Dalston. If you had the Snoopy framework, you could effectively give out drones to 50 likewise skinny jean, cool wearing haircut people and get them to spend a week period in Dalston. Find out how many skinny people are seen. Find out if there's really any uncool people with HTC phones, because let's face it, compared to the graph, only 5,000 have got it. They're not the kind of clientele you want. So you effectively have a distributed tracking project. You can look at demographics of people. You can figure out the movements of people. Do hipsters get up before 12? Do they start work at 3 o'clock? Do they work at all? And what kind of devices they do? So we've got a few ideas of where we want to take this project, and over to Glenn to explain them.
Okay, so in this project, we only looked at Wi-Fi. Looking forward, I think it'll be cool to look at other technologies. Point being that you can escape most of that stuff by turning off your Wi-Fi. But what about GSM and using femtocells or Bluetooth or any other NFC or RFID? The point being that we have so much kind of tech on us these days that is emitting signals. And as long as you have some kind of device that can detect those signals, you can drop these things all over some large area and track people down. Another idea I have is to drop so you can buy a 3G jammer for like $100 from a Chinese website. So strap a 3G jammer to this thing, such that all of your 3G signal now drops, and therefore most of your devices will automatically, regardless if they have good 3G connection, connect to my Wi-Fi here. And I'd like to start a website similar to Wiggle, but where Wiggle focuses on perhaps server-side war driving, so looking at actual APs. I'd like to start something called client-side war driving. So get enough people involved, submitting data to a website of observations of client devices. And I think we could get really nice visuals by getting a lot of people involved in a situation like that.
So a good talk wouldn't be the same without about the classic one more thing. And our one more thing is that in a couple of weeks' time, we're going to release Snoopy as available download to anybody. That includes the server-side code, the client-side code, the machines, the transforms, and everything else. So you can build your own Snoopy implementation and see how you get up to. So I guess that leads us nicely into questions.
Hello.
Hi.
Just a question. You said about attaching a 3G jammer to the phone.
Yeah.
How would you then connect back to your server?
Yeah, so point being you'd then need an Ethernet or some other way out. So the way I tested it was having an Ethernet connection plugged in somewhere.
I was just being pedantic.
Alternatively, what I thought about was you could jam the networks, make sure everyone associates to you. So this thing handles DNS and everything. So the client will think they're connected and then stop the jammer, at which point perhaps they're connected to you.
Wouldn't jamming be illegal in the UK?
So all of that stuff's illegal except for...
We did talk about a really fine line. You can listen to broadcasts, that's about it, really. Anything else, interception, well, you're kind of screwed, so give up.
Point being that no technology is inherently good or evil, it's what you do with it. So we didn't do anything illegal in this talk. We just showed you ways that you could if you wanted to, but other people do it too.
You mentioned you wanted to add in monitoring 3G signals, telephone signals, Bluetooth, and everything else.
Yeah.
If you did, is there any easy way to determine, if you're monitoring a particular device, all of its connections and linking them together in one graph?
That's a good question.
So I think, so it's an interesting area. We haven't explored it much, but definitely bring all that data together. So, okay, 3 days ago we observed this person by his wireless signature. Today we observed him by his GSM signature. Next week we observed him by his Bluetooth signature. And you'd have to figure out how to correlate those events. I guess at some point you'd have to have him maybe emitting both signals at the same time. Alternatively, if your femtocell is intercepting traffic and you browsed Facebook or whatever sites via your femtocell on this day and then via your Wi-Fi thing the other day, you can make that correlation.
I guess the other thing you've got to bring into there is that, again, the legal aspect, because you are intercepting traffic. So the moment you do that, you need to be in a territory that doesn't persecute people for doing that kind of stuff. So, somewhere nice like North Korea.
Come to Zimbabwe.
Zimbabwe.
Any other questions?
I think you answered my question, because is the Snoopy server intercepting traffic, and how do you get around Ripper?
You don't. End of.
End of.
I wish there was a simple way, but you just can't. It's not worth the risk, especially in the UK. If it comes to intercepting and doing anything else, anybody else's data, it's such a grey, murky area. We didn't even try and do it. We did it in the Black Hat network. So we thought, here's fair game. You come to a conference called Black Hat.
We did.
And if you want to connect to a wireless network called the Black Hat, well, there's certain things you can do. So Glenn and I thought, well, that's like kind of an invitation to have a bit of fun. And you'd be amazed at how many morons were on the Black Hat network. So we did collect data. We did see transactions going past. We did see stuff get purchased. But all's fair in love and war. It's the Black Hat network. You're a moron for doing that. Nothing was done with the data, but it proved the fact that we were able to pull into Multiego and effectively stalk people, and whilst they were browsing Facebook and buying stuff online and doing silly stuff with credit cards. So it is very possible, and it was done theoretically in Las Vegas, but that's the only other time we dared try and do it.
But perhaps the point being, we're not the first people to do that kind of stuff. So the technology actually dates back to 2006. So the first time people realized that it was possible to, respond to probe requests in that manner was, Dina released a tool back in 2006, 2005. But the thing is, back then, the market wasn't ready for it, I guess. There weren't that many, there weren't that many wireless devices available. Whereas today, as Daniel said, every man and his dog has some kind of wireless device. So that attack from back then is much more relevant now. And the man-in-the-middle stuff, there's nothing new there. It's just bringing together old ideas or different ideas to one kind of central package or one central location. And as a pen tester, when I do kind of wireless assessments and I try and mess with rogue access points and things, it's kind of a clunky process. It's a difficult process. So a lot of my thinking here is from my real-world experience. And I think we didn't mention in the potential uses, but one definite good potential use would be for pen testers. So you have stuff like Silica from Immunity, a few other products, but those aren't free, whereas this thing will be free. So perhaps as a pen tester, your target client, their firewalls and everything are jacked up. Well, let's hit them this way. I bet we can find one of their CEOs in a coffee shop or wandering around the street and hit them this way.
Any other questions?
Hi, Owen here. Just wondering, with regards to the servers, because obviously the agents themselves are just transmitting data, they're not really doing anything apart from relaying what they're receiving. Yeah. So if you're hosting your servers themselves in countries that don't particularly care about interception, in theory, does that mean you get around any of the legal issues, or do you still potentially get caught because you're transmitting the data from a country that does care about those issues?
I'm not a lawyer. I've got a fair amount of experience with Computer Misuse Act, but I'll be honest, I wouldn't risk it. You're in the UK, you're performing something that you shouldn't be performing.
So perhaps your question was, how can you do this and not get caught? So theoretically, what I would do, so once you turn this device on, as I mentioned in the kind of the architecture diagram, so you turn it on and creates an open VPN connection to that server. So that traffic's encrypted. So as far as interception by local law enforcement, it's question time. It's not my fault.
You keep talking.
Okay.
No.
So so what you would do. Lost my train of thought. Yeah, so you turn that thing on, it connects via OpenVPN, and because that traffic's encrypted, local law enforcement has no idea what's going on there. So even if there's 50 devices connecting to this, that one pipe goes to that online server, and that's encrypted. So no one's going to catch you there. Then if you host that online server, if you host that in Malaysia or Singapore or something, an OpenVPN solution over there or a VPS solution is like $10 a month. So no biggie. Only thing that might catch you out is your victim's endpoint will be a box in Malaysia. So if they go to Google, they'll hit Google, they'll be redirected to Google.ml, which might make them slightly suspicious, but so what?
I think if you do it, we'd be really interested to hear from you. By all means. It'd be quite cool to see somebody having the balls, because we don't have the balls to do it. So, over there.
Hi. Over here.
Where's that voice?
This is a question concerning the client AP, client broadcast collection and publishing. Where does that lie on the tracking of devices? Because you're essentially tracking individual handheld devices and possibly publishing on the internet. So you're publishing people's movements, maybe? I don't know how that...
When you say publishing, are you talking the stuff that we're doing in Maltego, or?
No. There was mentioning of putting together a database of...
so for future work,
future work,
war driving,
Yeah, I was just concerned of that in terms of a legal aspect.
So to be honest, if there's a lawyer here, maybe you can advise us, because at this stage it's a pipe dream. So that could be quite a cool idea. As far as legalities, I'm not sure.
I suspect the Data Protection Act might come into effect here, but we all know the Data Protection Act is pretty weak. Nobody's ever really been prosecuted. So you can lose a laptop with data, so why can't we publish data?
And also, have you used this technology to spot many feds, for example, at DEF CON?
No, but they're the ones wearing really crappy jeans and tucked in t-shirts. They're not hard to spot anymore at DEF CON. It's, spot the real hacker at DEF CON these days.
You mentioned that pretty much the only way to stop yourself from being vulnerable to this is turning off your Wi-Fi, but clearly that's not the most optimal thing in terms of, you know, usability and convenience. Are there ways to harden yourself against this without turning your Wi-Fi off?
It's a really good question. It's something that Glenn and I have struggled with. So we were trying to understand, why vendors kind of did this. So with anything Apple, it's damn near impossible to find out how Apple's doing it. So we kind of worked out that Apple seems to be sending out between 5 and 8 probes per device, and that there was no specific time frame in doing so. So I saw my device pop up in one of our scans, and it found a network for, you know, a place I was in Bulgaria, but that was 8 months ago. So the problem is there's no way of hardening a default iOS phone. You know, you can maybe delete them in, you know, your preferred networks, but what we noticed was those networks were still being probed out. We were talking about it earlier. Almost what we need is a network firewall on the device itself to say, listen, you know, only connect to this network. When I'm outside, you know, blacklist BT Open Zone, blacklist this network. But unfortunately, there's nothing like that exists at the moment. So you're kind of at a whim. You know, you don't use your Wi-Fi when you go out like we don't anymore, or, you know, you just leave it on and don't really care.
So the thing you need to do is you need to flush those lists. And on a MacBook or a Windows machine, it's fairly easy. Just go to the network settings and say, you know, the list of preferred networks, I think they call it, and just delete those, and then I'll stop probing. But on an iPhone, a non-jailbroken iPhone, the only way that we can, well, the only way I found out they can do that is you have to manually connect to that network and then say, forget this network. So you'd have to go to every place you've ever been to and, right, connect to that network, okay, forget. Okay, connect, okay, forget. So I think potentially what might be a useful tool would be, so this, the Snoopy device, whatever, it can bring up a network point. So you listen to your device, you know, tell it to only listen to the MAC address of this device for you, and then create those APs, and then you would connect to them kind of one at a time, which would be a little bit faster. But point being that you need to flush those lists somehow.
If anybody does create an app for that and sells it in the iStore, just think of us. We're broke from Africa. Think of the blackheads. Come on, help us out.
Maybe one point to mention before that gun shoots me. I mean, I assume there'd be a question in why does this device do that? You know, if there's an access point over there called Starbucks, it's sending out beacons announcing itself. Why must I shout for it? You know, when you walk around, you don't shout out the name of every friend you know in case he's around you. You'll see him, and that's cool. Does anyone want to know why? Yeah. So, okay, so I'll tell you the reason I found, and then please correct me if I'm wrong. And it seems to be, so for some level of usability. So if you're in a large organization that has lots of APs with the same name, so SensePost, we've got like a 10-story building, and we've got hundreds of APs all called SensePost. And now if I move from the first floor up to the second floor with my device in hand, and I lose reception from, say, the previous access point, and I want to associate to the next one, if I wait for that device, for that, you know, the access point to announce itself, there might be a delay in a switchover. So what the device does is it'll constantly shout out, hey, are you there? Hey, are you there? Hey, are you there? So long story short, for increased usability. Now, who's going to correct me if I'm wrong, perhaps? I saw some nods and some shakes. Where the man with the microphone is.
What about with the when you're going through Wi-Fi and you connect to a VPN service? If you connect to a VPN through the phone, what do you detect?
That's a very good question. I don't know if we ever tried that. We don't really have any VPNs to play with.
Yeah, sorry, I can't see you, so sorry, ask the question again.
It's the awkward dude who touches everybody.
So as soon as you get to the Wi-Fi and stuff, you know, it's like I mean, hopefully most people do it in security and stuff. You know, when you get to a security conference, you're going to go through your VPN service and stuff, you know, from
okay.
And it's like, so what do you detect from that?
Actually, we did test that with Adrian in the Business Class Lounge at Heathrow, and we did notice there's probes actually coming out first before he connected to the VPN. So there was that initial handshake of the Wi-Fi connecting, so we did nab him that way. Unfortunately, obviously, by then, him using a VPN, we wouldn't be able to do any interception.
And also, if he's using his VPN, perhaps he's already connected to your device. So he connects to your rogue device and then uses that internet connectivity to connect to his VPN. So you won't be able to intercept his traffic, but because, you know, that server can directly access his device, you can still run Nmap against it or Metasploit against it or smack it up some other way.
Right.
No. So again, it's not documented as far as I can tell, and it seems to vary. So sometimes yes, sometimes no. The easiest way to check is to fire up AeroDump. So this stuff uses tools from the aircraft suite. So fire up AeroDump, and it's a network tool that gives you a list of current probes and current associated devices. And you'll notice in that list that you'll see that a device is associated, but it's still sending out probe requests. Who knows why? It's, I do know why. I just answered that earlier. It's because in case you move location, it still wants to maybe connect to another network, but then it should just send probes for the network it's already connected to. I think that means it's the end. Damn it. Yeah, so I suspect if there's any more questions, grab us at the bar party thing. But yeah, thanks very much for your time.
Thank you.